Okay, so this is the notes video for Chapter 8, Lesson 5A, which is a hands-on lab. We need to be on page 633. Before we begin, I'm going to remind you of the rules. The directions that are on every single notes video say that you're supposed to read and take notes and watch the video, and then as the video goes along, answer the questions that are asked in the video. But we're skipping over the take notes part. Many of us are leaving our books blank for some reason. I do need you writing in your book. So from now on, the following assignment after we do a notes video will always be to take a picture of the notes that you wrote in the book. And they need to match what I wrote in the video. So if I write something, you write something. So let's test this out. I want you to write the word equation. Okay, so I write the word equation. You write the word equation. We're going to review what the word equation means. Now, while we're talking about rules, the book has information in it. So if you get asked the question, what's the most important thing, read the pages, go back and look at stuff and think of one important thing and share what you think is important about the lesson. And when you're answering the questions, as long as you're doing your best, I know these are brand new concepts sometimes, so I don't expect you to get a 100, but I do expect you to answer reasonable answers. And you'll make a 100 on the notes video. But if you say, I don't know, or IDK, then I'll give you a 50%. I'll reset the video, and you'll get a chance to go back and redo it and pay attention to what's important the second time. All right. Equation. We've all written the word equation, hopefully. And we're going to write an example of an equation. So first we're going to write the expression x plus 1. But once we put an equal sign, it's no longer an expression, it's an equation, and we are saying that x plus 1 equals 3, and that this is only going to have one answer. We can find out what x is equal to by using the inverse property, creating this zero pair here, and that is going to end up with just x on the left side. But if we subtract 1 from this side, we have to subtract 1 from that side. 3 minus 1 is 2, so equations only have one answer. This is different from what we're doing this week. This week, we're going to be studying something called inequalities. Now, they both have the same base word, equal, but the prefix in changes the meaning of this word. Now, I'm going to go ahead and write down in, and I want us to think of different words that have in as a prefix. For example, incorrect, invalid, inappropriate, indispensable. All of these words are changed, the meaning's changed by the prefix in. Let's use the most common one probably. You've probably heard this before, incorrect. Think about what the base word correct means. Now I want you to think about what does the prefix in mean? Go ahead and answer that for me. You're exactly right. In means not. So we have previously been working with equations where one side has to be equal to the other side, but inequalities are things that are not equal. You are not saying two expressions are equal to each other. You're saying two expressions, you're comparing two expressions, and sometimes they are greater than, one's greater than the other. Sometimes one is greater than the other, or it could be equal to the other. Sometimes the first expression is less than the other. Sometimes the first expression is less than or equal to the other. So we do have some situations in which may be equal or may be larger or may be smaller, but these are never going to be just equal and only equal, because if that was the case, you'd have an equation and not an inequality. Okay, so let's go ahead and look at this situation in which we're going to encounter an inequality. In saltwater fishing, any flounder that is caught may be kept if it is greater than or equal to 12 inches long. Any flounder shorter than must be released back into the water. Pat caught a flounder that is 14 inches long, and he wants to know if he can keep the fish. So we're going to have to compare those two quantities, and we'll do that with the hands-on activity below. So an inequality is a mathematical sentence which compares quantities. An inequality like x is less than 7 or x is greater than 5 can be written to express how variables compare to a number. Okay. All right, so we're going to label the minimum length of the flounder that may be kept. So we're come up here to the word problem again. And what I would like you to do is go back into the word problem and find the information. What is the smallest fish that could be kept? And I want you to go ahead and write it in that spot right there. Okay, so the top part of that bar diagram, you should have written 12. And you'll notice that they have a number line right underneath it. And number lines are super important when you're describing inequalities. So it starts at 0, it ends at 12, and this is the minimum size of fish that you can keep. It can be equal to 12, but anything less than 12, it has to be thrown back in the water. Okay. Now go ahead back in the problem, and you're going to label on this top part of the bar diagram the fish, the length of fish that he actually caught. Go ahead and do that for me now. All right, so if you said 14, you are correct. Now we have to compare. So we're comparing 14 with 12. Is 14 larger than the minimum and can be kept? Now we notice it starts at 0, ends at 14. So if I'm comparing 14 and 12, 14 is greater than 12, and so that can be kept. And I could also do it the other way around. 12 is the minimum. It's got to be 12. 12 is less than 14, so 14 is large enough to be kept. So the bar representing Pat's fish is larger than that representing, so it can be kept. Okay? All right. Okay, all of that should seem like things that we should already have known at this point, but in 6th grade, we're going to add the concept of variables to this. So let's say x is the length of fish, okay? And we want to write an inequality that describes what we can keep. So x has to be greater than 12. Anything greater than 12. But actually, it said it could be equal to 12. So a better rule would be x is greater than or equal to 12 is the inequality that we can use to describe the length of fish that we can keep. And that's the 6th grade level of this skill. All right, so let's apply these activities. Scratch that. Let's apply these strategies to 2 different activities. Now, the first activity, it says, for flights within the United States, luggage must be no more than 50 pounds. Imelda's luggage weighs 53 pounds. Can she take the luggage on the flight? So the first thing I want you to do is go ahead and draw the model on that number line, and then I need you to answer the question, can she take her luggage on the flight? Go ahead and do that for me, please. Okay, so my model looks a little bit different than theirs, but I have the dot where the maximum is. Between 0 and 50 is fine for luggage, but Imelda, it goes over the 50 to about 53, so no, she won't be able to take her luggage on the flight. Okay, now let's look at this other situation. If we have Byron, and he needs at least 20 minutes in between the end of his soccer practice and the start of his dentist appointment to get there. His practice ends at 4:30 and his appointment for the dentist is 5 o'clock. Does he have enough time? Okay, so we can see that this starts at 0 and ends at 30. So I want you to ask yourself, okay, so if I'm thinking about 20 minutes to get from one place to the next, is he going to have enough time? So answer that, yes or no, after you draw your model. Go ahead and do that for me. Okay, so it's okay if your models look a little bit different than mine as long as they are similar enough. I decided I would draw a box this time. So starting at 0, he needs between 0 and 20 minutes, he won't make it in time. But if we are going to have between 4:30 and 5, that's 30 minutes. So that's plenty of time. So yes, he's going to be able to get there. Okay. Now, let's go ahead and think about inequalities that would be used when the situation involves the word minimum. Okay, so minimum, and then the next question asks about maximum. The maximum piece of luggage that you could actually have, okay, hang on a second. I touched my pen and it actually disappeared everything. So the maximum piece of luggage you could have over here was 50. Over here, we needed a minimum. That's weird. Okay, over here, we needed a minimum, better, of 20 minutes. So we've actually done two different situations. One had a maximum number and one had a minimum number. So the max was 50 over here and the minimum was 20 over here. Okay, so which inequality is used when the situation involves a minimum? So if you need a minimum of 20 minutes, is that going to be greater than or less than? Now, is it going to be greater than and equal to or less than and equal to? Which one of those situations would be the best thing to use? Go ahead and think about that and answer that question for me, please. Okay, so I tried to write it out with my pen and my pen wasn't cooperating, so I just went ahead and turned the answers on. And this actually is pretty good because it shows their much neater models that they drew for both of these situations up here. All right, so the answer is actually greater than, and I would argue that maybe greater than and equal to would be a better symbol to use. So if there's a minimum, that means nothing less than that number will work. So everything has to be equal to it or greater than that number. So the situation they're asking for is the least value possible. All other values of the inequality would be true if it's greater than that minimum. Okay, now we're going to go ahead and answer the second question. Okay, this is the final question we're going to answer today before asking the big what's the most important thing question. Which inequality would be used in the situation involving a maximum amount? Please explain. Go ahead and answer that for me, please. Okay, if there's a maximum number and nothing above that number will work, then we're going to be focusing on less than. And I would also say that less than and equal to might be a better description. So if it's a maximum, then anything less than that maximum number is going to work out perfectly fine, but all other values that are more than that number will not work. In the situation in which we cannot bring more than 50 pounds on for your luggage, 53 would be too much, and so anything less than would be better. Okay, so now I want you to make sure you've copied down all of the notes that we did today, because you'll be taking a picture of that and sending that in the next page. But before we do that, tell me, what is the most important thing you think we should remember from this lesson? And if you don't know, please go back and look at both pages and give me a good answer.